Well, my friends, the first example of a function is as follows. Let's start with the following procedure. The procedure f, which simply says add +1 to the input. Well, I can choose any input, could be any real number, so the largest set on which this f can act is entire real numbers. However, in particular, I'm going to choose a subset of those real numbers, namely those real numbers between -1 and 2. So, as a result, so let's call it the domain of f, let it be, to be all those numbers from -1 up to 2, excluding the 2. Now, if f acts on such a number in this set, let's call it x, then by definition, I get add +1 to x, the number that you chose, which lives between in this interval. Now let's define the function. So this is the procedure acting on x, so it's the number. You see, this is a number. And now let me write the function. The function is as follows. So you have the procedure f, given here, which maps elements in this set from -1 to 2, excluding the 2, to elements in R. So this is the range, the codomain. Okay, the range is quite different, so this is the codomain. And now every element x, which lives in this set, is going to be mapped to this number, f of x. But f of x is an abbreviation for this number here. So add +1 to x. It's cumbersome to write this thing, because I'm explaining what the number is. So in mathematics we use a special notation for this, and you already know what it is, so you just write x plus 1. So here is the element, the symbol for the element that lives in the codomain, which also is abbreviated by this thing here. Now, this is the function. So the function is this entire thing. You need to specify many things. Let's draw now, draw the graph. What is the graph for such a thing? So this is one point of view, the procedure point of view for the function. Now let's see the graphical point of view. To do that, let me first try to see what are some of the order pairs that are in this function. So let's start with the procedure point of view and now try to construct a table which on the first column has some of the x's that I choose in this set, the domain, and on the second column has the f of x. So let me choose -1, for example. It could be 0, it could be 1, and it could be 2. However, we have to exclude 2 in the end. But as an auxiliary point, let's use it. Moreover, now let's compute the thing. So it's -1 plus 1, which is 0. So it's 0 plus 1, which is 1. So it's 1 plus 1, which is 2. And finally 2 plus 1, which is 3. This table has some of the order pairs in this function. So let me write it like this. So it's -1, 0 for the first row, then 0, 1. By the way, I should write it like this. It's -1, 0, then there are many other real numbers between -1 and 0, so the dots here. Then you find 0 and 1, and then between 0 and 1 there are many real numbers again, so dots, and you get 1, 2. And finally, there are many real numbers between 1 and 2, so let me write the dots, and you get the 2, 3. However, the 2 and 3, the endpoint here, should be excluded, so I'm going to put this symbol here, this bracket. So you can see here all the order pairs. all the order pairs that I computed, okay, the entire set I cannot compute, okay, because there is an infinite number of x's in this interval. So this is just some of them. Now, with just some of them, well, it's good, because let's do a plot of them and then try to extrapolate what are the remaining ones. So let me just draw here. The horizontal axis represents the x values, which must be between, let me see, -1, should be 1, this is 2, okay, and this is 1, 2, and 3. So let me draw in blue now these dots here. So -1, 0, it's here. Then 0, 1, 0, 1, it's here. Then 1, 2, 1, 2, it's here. And finally the 2, 3, it's here, but it's open, because it does not belong to the f function. Now, just with these few points that we just computed, you can already see that this is a line. You see, you can understand what are these points here, the intermediate order pairs, because those intermediate points are those here. Can you see? So this is a line. Up to here. Can you see? So now you have this point of view. It's quite easy, just a single line. And observe that this is just a sketch of the thing. Okay, this is it's just a way to guide us on what it means, this function. And you can see on this graph, first of all, the domain is here. So this is the domain of f. It's just this section from -1 to 2, excluding the 2. So to make it explicit, let me write it like so. Closed. All those points up to here, open. So this is the domain. And now that I have the graph of the function, it's easy to get the range. Because you see, this is the codomain. It's the entire vertical line. But the range is different. It's only the y's that are in this set. And as a result, you can see here that all the range goes from, let me write it in green, it's all those points from here up to here, but open. So each one of these points is a y in the range. So the range, let me write it like so, the range of f must be between 0 and 3. 0 and 3, excluding the 3. Okay? And the range, notice, is a subset of the codomain. One final observation for this graph. Notice that this time I was able to sketch the entire graph of this function. Many times, as we're going to see on the next example, this is not the case. Okay? So, that's it, the analysis for this function. Now let's move to another example.